We kind of did a problem like this yesterday where we were applying our area formulas. It is that very last problem on the notes page. These are called the missing component problems or find the missing measure problems, where they're going to give you the area. You have to work backwards and find whatever piece is missing. So the very first thing that I recommend you do whenever you start one of these problems is write out the formula for the shape that you're looking at. So if in number 1 it says find the area of a rectangle is 120 inches squared, then the first thing you should do is write that the area equals base times height. That's the formula for a rectangle. Once we do this, then it's very easy to see what things we have and what things we need to find. So the first thing it tells me is that the area equals 120 inches squared. So I'm going to plug that in for A. Then I know that the base is 13. And I don't know the height, so it's going to stay as a variable. Then we're just doing algebra, reverse order of operations. To figure out what that missing variable is, I should divide both sides by 13 to get that my height is 9.2. I am going to be picky about your units. So anytime we're talking about area, that's where we use units squared. Every other time, base, height, diagonal, whatever it is, that's just going to use regular units. So that's why this is 9.2 inches. Not inches squared. Make sense? Pretty easy? Let's keep going. Number 2 gets a little bit more complicated, I think. We are looking at the height of a parallelogram is 3 times the length of its base. If the area of the parallelogram is 432 feet squared, find the base and the height. So it doesn't actually give us any of those measurements. It just tells us what they are in relation to each other. I'm going to start the same way. The parallelogram has the same area formula as a rectangle. It's base times height. I know the area is 432. But I don't know the base or the height. So I'm going to have to start with what I know. The height of a parallelogram is 3 times the length of its base. You should literally be writing out that the height equals 3 times b. Or just let's write it as 3b. Okay, so we're going to plug this in now. My formula is the base, which we're going to call b, times the height, which is 3b. Make sense? B times 3b is 3b squared. Oops. And again, order of operations here, divide by 3 to get 144 equals b squared. Square root both sides to get your base is 12 feet. Do not forget to go back and plug that 12 feet in to find that the height is 36 feet, 3 times 12. Questions on that? I'm not doing anything too crazy. Okay, let's do another one. Number 3. Area of a triangle is 35 centimeters squared. As soon as I see what shape I'm using, I'm writing out my formula. Area equals 1/2 base times height. This one's nice and easy because I know the area and I know the height. So I can just go ahead and plug those guys in. 35 equals 1/2 base times height, which is 10. I'm going to simplify the 1/2 and the 10 because I can multiply in whatever order I want to. So this is 5b and divide by 5 to get 7 centimeters equals the length of your base. I feel like we're good on those ones, right? The ones that get tricky are the ones where we don't know either of the pieces. So let's take a look at number 4. Again, height of a triangle. I know it's a triangle. I'm writing my triangle formula. Area equals 1/2 base times height. That's where I'm starting. I also know that the area of this triangle is 60 square inches. So I can plug that in for A. Here's where things get tricky. I don't know the base. I don't know the height. What am I going to set up here? What do we think? How does one variable relate to the other? I got B and I got H. Any ideas? How would I say the height, H, is 7 inches more than the base, B, Caitlin? Exactly. The height equals base plus 7. So now I'm going to plug that in for my height. I have this equals 1/2 times my base times height is B plus 7. Everybody see where I got that number from? Or those variables from? Okay, so now we got to be a little bit careful. I don't like working with fractions. If you don't mind fractions, that's totally fine, but I know a lot of us also don't like fractions. So I'm going to get rid of that 1/2 by multiplying both sides by 2. That is the very first thing that I am going to do. Then, kind of similar to that last one we did like this, but I have a plus sign in the middle. Anytime I have a plus or a minus sign in the middle, and I've got a number out front that I'm trying to multiply, I have to do distribution. So this is 120 equals B times B is B squared plus 7B. Do not forget to distribute. And I know you roll your eyes because, oh no, we're going to have to factor this. It shouldn't be too bad. It equals 0. I believe the factors of this, if we go through and try to figure out what multiplies to 120 and adds up to 7, I believe it is 15 and 8. Does that look right? Yes. And then to get to a positive 7, I want a plus 15 minus 8. So I have two answers. Negative 15 and positive 8. Do both of those work in this situation? Can't have a negative side length, so I know that negative 15 does not work. So my base is 8 inches, and then I got to go back and find the height. The height equals 8 plus 7, or positive 15 inches. Any questions on that? Okay. Let's do a trapezoid, because I guess we haven't technically seen a trapezoid yet. This one's not too bad. Also a simple one where we've got the area, we've got the height, and we have one of the bases. So I'm going to start by writing out my formula for a trapezoid. 1/2 height times base 1 plus base 2. Area is 210. 1/2. The height is 6. The first base is 20. The second base, we're going to leave that as base 2. I like to take care of those fractions right away. So 1/2 times 6 is 3. Divide everything by 3. 70 equals 20 plus base 2. So base 2 is 50 yards. All good. Let's do, I don't want to do the kite. Let's do the rhombus instead. Kite and rhombus have the same formula, so let's just make sure that we use this formula at least once. The diagonal of a rhombus is half as long as the other diagonal. If the area of the rhombus is 64 square inches, what are the lengths of the diagonals? The first thing I'm going to do, write out that formula. I'm going to figure out what do I know. I know that the area is 64 square inches. And then I need to relate the two diagonals, diagonal 1 and diagonal 2. It doesn't tell me which one is which, so I'm just going to start with 1/2 D1. Then how does diagonal 2 relate to my other diagonal? How would I write D2? I'll write it off to the side for now. How does D2 relate to D1? Caitlin? I would say, yeah, we could do that. If I'm reading one diagonal is half as long as the other diagonal, I would write this as D2 is half of D1. That's what makes the most sense to me. If you want to like run it backwards and do a 2, I think that's fine as well. So I'm going to do I'm going to do 1/2 D1, just because that's the way that I think of it. If you want to do 2 times D1, that's fine too. So 64 equals 1/2 D1 times 1/2 D1. I can multiply all of that together. 1/2 times 1/2 is 1/4 D1 squared. This isn't too bad. I can just multiply everything by 4 to get 256 equals D1 squared, or square root, to get 16 equals D1. And that's 16 inches, I believe. So then D2 is 1/2 of D1. So D2 equals 8 inches. You should get the same thing if instead of 1/2 D1, you said 2 D1. Should be the exact same. Any questions on this? You feel okay about it?